Good afternoon. Welcome. My name is Tommy van der Heijden from MarXact, and today I'll be taking you through the journey of why smart cities are impossible with traditional surveying methods. First of all, let me start with a small introduction. Already told my name. We are founded as MarXact in 2017 together with my partner Raul, with the intention of making centimeter accurate surveying easy and affordable for any field worker who knows how to use a smartphone. Since 2017, we've been growing insanely fast, making an international team with in-house development of products and the accompanying support. We are, as you could say, a traditional, well, not a traditional, but a startup trying to completely change a business or a business way because of our idea that surveying should be easy and affordable for any field worker. So what I'll be talking about in this presentation is what a smart city actually is in our terms, and what this geodata has to do with it, who controls this geodata, how that traditionally goes versus the new wave, how we would like to see it, what happens if you experience a malfunction while surveying, speaking about our solutions we offer, and also take some use cases of organizations that already have taken surveying into their own hands to work smarter and not harder. In the end, we'll recap a little bit and also explain about the fact that the investment to make this happen shouldn't be that big. And of course, I'll end up with a call making sure that everybody knows that smart cities are only possible if we enable the non-surveyor to survey. So what is a smart city and what does geodata have to do with it? As we all know, a smart city is a urban area using different types of electronic methods and sensors to collect data. We use that data to efficiently manage resources and our services in the city. And in that way, we can improve the city operation. We can change the way residents behave. We can think about how we can make it more economical, make it more ecological. There's a lot of benefits of a smart city. And there's also a lot of geodata involved in it. We need to know where the sensors are. We need to know how the sensors are connected to each other, and what sensor talks to which sensor, and also what the effect is if one sensor is not available anymore. So we need to know with centimeter accuracy where the cables are, where the fiber optics are connected, how the pipes are running through the city, because of course you can imagine if the smart city that's linked to each other goes down to an interruption, we need to fix it. So now we know what the geodata has to do with the smart city. We can take a look into who controls this geodata. Well, generically it's the client, the government, like the one that runs the city, who controls, of course, the geodata in many of their GIS tools to make sure that they have everything available. But apart from that, there are, of course, more people and more equipment involved. The surveyor can obtain the data, can be an in-house surveyor, an outsourced surveyor, and we can think about how that data is used in a sense. I mean, is it digital? Are it paper drawings, which still happens from time to time? Can we use a GNSS equipment, or do we need the measuring tape? How is the data processed? As I said, we still have places, unfortunately, where everything is on paper, but we also have government where everything is in a data cloud. We have somewhere in the middle where it's stuck on some old server in the basement. We need to think in terms of controlling who has access to that data. Is it private to one person, or do we share that data? The next step is the example of fiber optics, where you see what the difference is basically between having that data available or not available, which ties into that access, also the use equipment, how it's processed, and so on. What I'm going to explain you in this situation is, first we're going to talk about what the original and traditional way of laying a new fiber optics cable was, taking into account that not everybody has access to the geodata, taking into account that we have outsourced surveyors, that we have a more old-fashioned process, and then apart from after that, we're going to talk about how you can do that faster. So if you look at the traditional way, of fiber optics and the design, you would see that the design is traditionally made or loaded into Cocon, which is an online platform. It has a data cloud behind it, so it's already a little bit modern. Let's take that as a starting point. There on a Monday, based on the current network, based on the housing, based on the availability, a network is designed, and let's say that happens on a Monday. At the end of the day, the data gets exported because it's ready for construction. Then on Tuesday, a surveyor who is hired by the constructor will import the data into his own tools. We'll do a stakeout, put some gravity on the ground, add some marks to make sure that on Wednesday there is a crew who constructs the cable. When that crew arrives to the site, one of the first things they do already now is they take their iPad or their tablet and they open it, they open Cocon, and they are seeing basically on a map, they're seeing what they need to construct. They have all the data available, but still they have to search for the gravity points or the staked out points done by the surveyor because there was no link. And construction takes place according to where the gravity is. Of course, the surveyor does not have the full insight on what's inside the ground. So once the ground is opened, they might find some old tree roots. They might find some other stuff which they have to go around to make sure that the cable can be there. So basically what you would see typically is that at the end of the day, let's say 90% is constructed according to plan, but 10% is not. The ground needs to be closed because that's what we've decided with each other. And there's no time for the surveyor to arrive before the ground is closed to actually take on the as-built situation. So let's say that a guy or girl arrives on Thursday to survey what's actually been constructed. He will find a closed ground. He would have to guess basically where more or less the cable is, and he will do the actually as-built survey of the constructed situation. Let's say 90% is good. Already that 90% which is good, still it's being surveyed with closed ground. So whereas the traditional methods or GNSS methods or total station has millimeter to centimeter accuracy, it doesn't really matter because you're surveying closed ground. So how accurate is it actually? But that's what happens. So at the end of the day, he makes the export of that data, which gets to the fiber optics company. The data is then again being imported, it's being revised in Cocon and basically marked for completion. It's kind of an optimal process because in this way we presume that the surveyor, the engineering crew, the construction crew is all brilliantly available at the same hours, great after each other. In practice, this process is usually, let's say, 1 to 5, 6 weeks, depending on how well or efficient those companies are operating. So going to the new wave and the new way of surveying, what we need to do and what we need to make happen is that we open up the geodata and to make sure that in this case, like the construction company actually has access to that data. So what then can happen is that on the Monday morning, I mean, I just took a week, which was incredibly brilliantly efficient, which wouldn't happen in real life. So I'm now going to do the same example with New Wave. Of course, this can make maybe 1 or 2 days, but let's take that in mind. On Monday, the crew would design in the morning, early morning, they would design a network in Cocon. One of the first integrations we've made, leading to making smart cities more smart and more possible with non-surveyors, was an integration with a company called Spear IT. They made this brilliant tool called Cocon, and Cocon is basically the fiber optics registration platform. So network owners of fiber optics, call it British Telecom, call it Eurofiber, they have their networks registered in Cocon. And by making a link to the Uni cloud, and they can now have the construction crew on the site do the actual surveying directly into the GIS tools. But that's the old way. We're now going to talk about the new wave of doing it, where geodata is more accessible, where we allow the non-surveyor to survey, where we're more open-minded about how we're going to handle that data. to make sure efficiency is achieved. So what would happen in a new situation is instead of 1 full week, we could do it in 1 day, meaning that while the construction crew is on their way to the actual location where the construction will be done, the design engineers will finalize the design in Cocon and upload it into the cloud. When the construction crew arrives to the site, they will open, like they would anyway, they will open the Cocon tool. They would see the drawings, they would see the online geodata, but additionally, they would also see the surveying GNSS antenna, which they have in hand, which can be the Uni, connected through the cloud. And what then can happen is that the foreman of that job can actually stake out what needs to be constructed while his crew behind him is already lifting the tiles from the ground and start digging. What you would see is that where the foreman hits the end of the line, then already the cable can be laid at the beginning of the line. Meaning also that when they run into problems, they can at that moment efficiently see, according to the geodata, where they could construct the cable in a better sense, and they have more flexibility because they actually have access to the geodata while working in the field. So at the end of the day, when the fiber optics cable is in the trench with an open trench, they could survey where that cable actually is, and then the ground can be closed. And at the end of the day, not 90% of the data is halfly measured well. At the end of the day, we've surveyed with open trench, so with centimeter GNSS accuracy, the non-surveyor has actually pinpointed the actual X, Y, and Z, so the depth of the cable, and done the surveying before the ground closes, leading to the fact that in the end, while they're closing the ground, the revision drawing is already in the cloud, is already there. So theoretically, in the office, the engineers should just click the button and the line can be in use. So this is a great example of the construction of smart cities. Let's talk about what happens in the process when we experience a sensor malfunction. So in general, let's take into our minds that we have a lot of things connected in the city. We've got the traffic lights, we've got heat sensors, we've got air pollution sensors, we've got a lot of things that intertwine to each other. And in our ideal future, we need all that data to be available constantly at the same time, where algorithms make sure that we can live better in our smart cities, right? So what's really important is that going forward, we need to make sure that whenever there's a breakage, because breakages happen, we need to make sure that the breakage gets restored as fast as possible, because every moment we don't have access to the data of that smart city, the smart city is kind of useless, or at least a part of the city is useless. Of course, there are different levels of severity. Since COVID, we've seen how important it is to be online as a city and to have access online. So, I mean, I think we can all understand. Let's imagine that in the old situation, a sensor malfunctions, call it whatever it is, but it is a cable in the ground in this case. So the error arises with the sensor, being that the sensor is offline. So the client, local government, the city calls maintenance or uses their own maintenance department who inspects the sensor, and they would conclude like, okay, the sensor is just fine, there's nothing wrong with it, but there's a cable breakage, making sure that the data of that sensor is not correctly being transmitted to the end receiver. So that would be on step one or day one, as you would call it. Then the digging crew is called in. The digging crew, of course, needs access to the GIS data. They need to know where the cable is. They need to know where to dig, which can determine where the breakage actually is. They can do that by reading out the cable, by shooting signals over the cable to determine, like, okay, the breakage is about 50 meters into the line from this point. We've got great tools that you can use together with GIS to actually pinpoint that location on the map. And the way to make this faster is, again, opening up that GIS tools and opening up the access to that tools with smart surveying sensors to make sure that the digging crew actually is able to to pinpoint the location and just start right away. So like let's talk in new wave solutions. What would happen is that the error arrives with the sensors offline. The maintenance party comes in. The maintenance party is in that case equipped with a Uni or any other GNSS receiver that can be connected to the GIS data, and what he does is he comes to site, he sees that it's not the sensor, he has the equipment to pinpoint the location on the map. He also has the GNSS receiver to pinpoint that location in real time. So instead of like calling in 6 different crews, he alone can at least pinpoint the location where it is. Let's say it's ground, and then he can open it himself. Let's see, he has to call in a digging crew. The guys can be there within half an hour. He can open the ground. Of course, the first thing that needs to be done is that the client should either give that actual location to the digging crew, or the digging crew needs access to the GIS data to actually pinpoint the location. Once they have that location, what usually happens is they find out that it might be in an urban area, but it might also be that buildings that are on the map or certain GS data on the map is outdated and they cannot use traditional methods, so they cannot use their measuring tape. We can all imagine what cost is of breaking open too much ground, let alone if we're talking about a big city with traffic. So we need to make sure that we pinpoint that exact location. 9 out of 10 times you would find that instead of just simply digging and finding it, a surveying crew is called in to pinpoint location. Sometimes the digging company or the construction company has his own surveyor. Sometimes that needs to be outsourced. Sometimes it's the government that has it, but it's always a process, right? The guy needs to be called in. So we're on the step 3. We're going again a couple of more hours in, and then the surveyor comes to the location. Finally, he pinpoints the location. If the digging crew is still there, they can start digging. Usually, the digging crew doesn't arrive at first, so usually it's just like a foreman inspecting the location. So in step 4, when the digging crew actually comes to break open ground, find the cable, then the sensor is back online in no time, which is great. But we've got 4 big steps. Takes a lot of time. Ideally, if it's like a real time consuming or like a time sensitive matter, then of course this can be done within a day or within 2 days. But it's tough because you got so many parties that have to act together. You've got so many data that can be intertwined, so you need to make sure that this is faster, so the maintenance crew can determine everything that needs to be done and then call in the digging crew right away and get to work. So basically what you would see here is that in case of a malfunction, if you open up the data, if you give access to non-surveyors, if you make sure maintenance crews actually know where to go, then you have just more efficiency. You have your sensor back online way faster, and that's what we want, because in the future we cannot afford it economically or just in comfort sense to make sure to have outage of those sensors. So apart from the efficiency that we can achieve in the construction sense or when an outage happens, I also want to talk about a more pressing issue, and that's the fact that we are seeing a decreasing availability of the land surveyor. Even though we're trying our best, we're trying to educate more and more young people to go into surveying. What you traditionally see is that those surveyors will go into great new techniques, laser scanning, like the drone techniques, etc., which is where you want the knowledge of a completely trained surveyor. So what you basically would want to do on one end, of course, is to find more surveyors, to train them more, and to make sure that we have more of them. But at the same time, we want to lighten their workload by making sure that the availability of land surveyor is not consumed by small reconstructions in a smart city. We want to make sure that we use that surveyor for big projects where their knowledge is needed, and we want to train the foreman of a construction job to do the easy surveying part. I mean, anybody can work with a pre-set up RTK GNSS receiver. I mean, it's just turning it on, wait for a fix in open field, and you can get going. And you might not experience millimeter accuracy, which the surveyor can get to when he uses various techniques in GNSS. But we're talking about opening the ground, so we're talking about the size of the shovel that needs to be at the right spot. So if we are in the barrier of 1 to 5 centimeters, the foreman can work with an RTK GNSS receiver, and we don't need to hire the land surveyor to do that, and the land surveyor can be used for more important work. So how are we going to tackle that? We're going to tackle that by of course, our Uni Solutions. In general, I would like to say that I think it's time for all of us companies in the geo sector to talk about and to think about this issue on how to equip the foreman with tools that he can use, and where he can make sure that he doesn't make errors, and he can lighten that workload of the surveyor. Well, what we have created for them is the Uni Complete set, which basically is all you need to start surveying tomorrow. It's an easy to use, high precision Uni GR1 receiver, which gets you your centimeter accurate data in local coordinates. Everything is pre-set up. We are really aiming to make sure that any field worker who knows how to use a smartphone can use this equipment to survey, to stake out, to do the easy work. And that's the basic. That's the basic knowledge, and then the basic steps we need to take to encounter this issue. I think, and I encourage everybody to think about that, because it's time we realize that some of the traditional surveying work needs to be shifted to that foreman, to lighten the workload of the surveyor, and but also to make smart cities more possible. So I've run quickly through what our complete set is, and let me explain you a little bit more what that set consists of Uni Solutions. Uni Solutions is not just Uni Solutions for no reason. Uni stands for universal, and in that sense, we've got various products. We got a universal GNSS receiver, first one, number one. We've got a universal cloud, a universal connect tool, and we've got a universal RTK network. Can only expect from the foreman to take over the easy surveying job. I think I'm getting a little bit short on time, so I'm going to run through it a little bit faster. But here's just an overview of partners we already have connected with the UniCloud API, and that leads to great examples. I mean, if you look at Weiss and Freitag in Germany, they actually have the crews themselves who are laying fiber optics within big parts of Germany. They've got their process optimized with GeoLink. GeoLink combines a lot of geodata from local governments, from water companies, from basically the whole own databases of the network operator. So what I've heard from them is that by using this combination, they skip about 50 steps in the process of constructing a fiber optics cable. Same goes for BAM in the Netherlands, where they lay fiber optics as well, and they immediately register the as built in within Cocon. So while the ground is still open, with open trench, cables are being surveyed, directly delivered in the end tools, and the cable's ready of use. Lastly, we've also got, for example, Straba working with our equipment. They use it for sewery, to make sure that the foremen and the teams in the field don't need to hire the surveyor to actually get the work going on faster. They do that with our Unique Connect measurement tool and the Unique Cloud. So as you see, it's a beautiful example of various companies who do it at different levels, but in any of those levels, they are achieving efficiency. So in recap, to make smart cities more possible, I think indeed we need to rethink the use of geodata. We need to rethink how we have the processes optimized right now with a traditional surveyor, and how can we do that with a non-traditional surveyor. That means that we need to think about how do we obtain new geodata, how do we obtain access to it, who's controlling this data, who can give access to that data. What happens when there are problems with the surveyor data? Are we going to let 90% of the surveying work be done by the foreman and 10% of the hard work by the surveyor? Or do we want 100% be done by the surveyor because of that possible 10 error margin, right? I mean, I've talked about it with a lot of my clients. They all initially they would say like, okay, but we cannot do this because there are certain situations where we really need the surveyor. My answer is always, okay, how much percentage of your work is that where you need the surveyor, and how much can be done by the foreman? I mean, you cannot expect a 100% solution. We cannot expect that the foreman takes over 100% of the surveying work. I mean, that's impossible. But if he takes out 90% of the easy workload, that's still a big step in efficiency, which I think we need to take, and then we can actually use the knowledge of the surveyor for the 10% where it gets interesting for him. So as we've said in the beginning, we need to work smarter, not harder, and like preparing yourself for the future demands does not have to be expensive. I mean, if you just look at the cost, like the receiver is about 3,000 euros. You get your cloud, you get your support, you get your RTK access, like 1,500 euros yearly subscription, which you need to make sure that anywhere out in the field, you not only have correction data, but also have your data synced right away into the cloud and to your own databases, but as well where you have your support access, like where you can actually call us and the foreman can ask the questions like how to get going forward. We make sure that the guy can or the girl can. Lastly, of course, we need a fiber optics pole and a tablet cover to like the accessories for the equipment to work. Like in total, you get like 94, 95, and then for 1 year, you equip the foreman with a full set to do the surveying work. After that, it's just 1,500 a year. Most of our clients they earn this back within 1 or 2, some 3 months. Of course, 49.95 is a big number. It's interesting to see how that turns back into actual surveying work if we're thinking about pipes and cables. This example is done about with writing off the equipment within 3 years, and if you do that, then basically, if you would see that if you work 1 hour per 2 weeks, then you pay 118 euros for that hour, which sounds expensive, but if you survey 300 meters, it only costs 40 cents a meter. If you have the foreman in construction, which actually is the case, I mean, the guy lays cables every day, so he needs to survey every day, 1 hour, let's say he lays 300 meters a day, and you're talking about a cost of just 4 cents a meter, which is nothing if you compare it to hiring a surveyor. I mean, for those projects, you would need to hire a surveyor every day as well. We all know the prices. So you can see that this is not only more efficient in terms of data or in terms of keeping your city online, but it is way more efficient as well on the cost factor. And well, I mean, the cost you can save here, you can spend on more intelligent sensors for the city, which I think is the way to go. So to sum up, as an end call, I believe that smart cities are only possible if we enable the non-surveyor to survey, not only goes for smart cities, but far beyond that. In a sense, I think we need to put the customers and the end users and their needs at first and allow for open software systems. Enable data to flow through every system. Don't close them up. Let your customer choose how they want to work, and make sure the surveyed data is handled carefully, but also make sure that you enable non-surveyors to work with it in the sense that it can make your company more efficient. But I think we should think about which data needs which accuracy and who can be delivering that accuracy in which situation. And I mean, it needs change. We're committed to that. I hope you are with us on that. And in a second, we can discuss this way further. I have all the afternoon and evening if needed planned to speak about it. So feel free to hit me with any questions you have in a second. If you don't want to do them today, but later on, or you just want to contact me on the site, here's my contact details. Feel free to reach out. And I'm here for your questions. So stay tuned in this room, and thank you.